Good morning, Tehmina Khan is here in TKMaths is fun. In today's video, we will see how many of us can understand maths just by reading in words, just like a word problem. That's why it is a problem for most of the student. When numbers, mathematical notation, symbols are given there, everybody solve it very comfortably. When it is given in words, it's a problem for most of the people. So let's see here what is the meaning of this. The frictional force is only as large as is necessary to prevent motion. So what does it mean? So I have drawn a diagram here to save time in advance. So let's see you understand well now or not. I am sure you will be able to understand. So this is the body or the object here on the plane. I have taken different colors. So plane is represented by orange color, maroon color, right? Okay, so now F is the frictional force, 10 Newton is the applied force, which is in the right hand side direction. R is the normal reaction, and the body weight is 10 G, which is 100 Newton, right? G is equals to 10 Newton. So will this body, now the question is, the coefficient of friction between the body and the plane is 1/7. R I have told you normal reaction, F is the frictional force. So question or the statement initially was given, the frictional force is only as large as is necessary to prevent motion. So first of all, we have to see here what? We have to see what is the maximum frictional force here, right? Maximum frictional force. And then we will find out the magnitude of F which is applied in this question. Mean how much frictional force is necessary to prevent motion in this case. Will the maximum will be applied here or not? Okay, and then we will decide either the body will move or it will remain at rest. Now that is understood that if the force which is applied, here example it is, here it is 10 Newton. If 10 Newton is greater than the frictional maximum force, then of course body will move. But if 10 Newton is smaller than this force, body will not move, right? So let's find out first of all what is the maximum frictional force here. For that you need to know the formula. So maximum frictional force is F is equals to mu r, right? And mu is given to you, frictional force is given to you in the question, which is here. Coefficient of friction, which is represented by mu, is 1/7, which is given to you. And R, which is the normal reaction of the body and the plane, right? The force exerted by the plane to the body, which is the Newton's third law of motion basically, right? So what is that? R you have to calculate. So R is equals to 10 G because it is equal and opposite to the weight in this case. You can see here, this R is equal and opposite and body is not moving in that direction, right? So that's why they are balancing each other. So R is equals to 10 G, which is R is equals to 100 Newton. So that's why we have calculated the maximum frictional force between the body and the plane is 14.3 Newton. But what is the force being applied here? 10 Newton only. It means maximum frictional force is more, so body will remain at rest. So what is the value or the magnitude of F in this case? Do you think the magnitude of F will be 14.3, which is the maximum frictional force? No, it will not be. Rather, it will be 10 in this case. And you know how you can understand this? For example, this is you standing and somebody is trying to pull you, right, by 10 Newton force. And the maximum force you can apply is 14.3, right, to stop this motion. But when only 10 Newton force is being applied, you will not exert this force. You will only exert 10 Newton to prevent the motion. Agreed? So you will not waste your energy, in layman language I could say. So you will only apply 14.3 Newton force when the maximum is required. Right now it is not needed. So you will only apply 10 Newton force to prevent the motion. So let me just clear it out a bit. So you can say that the body will remain at rest because the maximum frictional force is greater than, let me write here maximum. The maximum frictional force is greater than 10 Newton. That is 14.3 is greater than 10. So body will stay at rest. And the value of F in this case is only 10 Newton to prevent the motion. Now let's see how much you understood. I have changed the diagram. Instead of 10 Newton, now I have taken 14 Newton force, applied force to move the body. Now body will move or not? Because R is exactly same, situation is same, weight of the body is same, the force applied by the body is same. So it is still same maximum frictional force. So now you tell me, what is the value of F in this case? Its maximum capacity is 14.3, but is it applying the same Newton force to stop the body or not? Or what it is applying right now? Only 14, because 14 is being applied to move it. So frictional force will act only with the magnitude of 14 Newton, right? And body will remain at rest because still the frictional force, the maximum capacity of the frictional force is what? Greater than 14 Newton, right? So the value of F will be 14. Now let's see the third case. Now the applied force is 20 Newton. The rest of the values are all same. So in this case, what will happen now? Because my maximum frictional force, which I have calculated earlier, was 14.3. So 14.3 is less than 20. So now body will accelerate. And what is the value? Value will be 14.3. The common mistake made by student is they forget to mention here what is the value of F in this case. It is 14.3. So when the body is in motion or at the last stage, the maximum it can go is the maximum frictional force it can take, right? Now let's see this. This is the last case. I have made it a little complicated. So now you can relate it with the statement I gave you earlier. The frictional force is only as large as is necessary to prevent the motion. So we have seen here the maximum frictional force was 14.3 in the three cases, right? Three cases. But in each case, the value of F was what was required here to stop the motion. Okay. But the moment it exceeds the limit, then value of F is the maximum frictional force. What will happen in this case? The situation has changed. So I will calculate my maximum frictional force again. Mu is same, which is coefficient of friction 1/7. But what is changing here? R is changing here. Now we will calculate R again. And I'm sure you would know how to resolve the forces horizontally or vertically. So accordingly, I have done here and calculated R is 86 Newton now, right? And because R direction is up and this vertical component of the force is up, so I add it up and opposite is 100. Why did I equate it? Because no motion is happening vertically. So these forces are balancing each other. Okay. So now once I know my R, so let's calculate the maximum frictional force, which is 12.3. Now I will see what is my forward frictional force, horizontal frictional force in this case, right? That is the force in the direction in which the body will move. So now if I see here, that is 24.3. So I am pulling this body with the force 24.3 and the frictional force is 12.3. So what will happen? Body will accelerate, it will move, right? And what will be the value of F? Value of F will be maximum frictional force because it cannot exceed that limit. So the value of F is 12.3 and body will accelerate. So thank you very much for watching. You can share it with your friends if you like it. Take care. Allah Hafiz.